So to be very specific, we consider this example. Say we have 4 different instances. Let us temporarily see these 4 instances are documents, and at each location or at each part of the data instance, there is a token. By token, I mean the smallest unit that we capitalize information in a document. So we can consider it as English words or mathematical samples when you read a paper, maybe. And it can be of a finer granularity, such as characters. Okay, and this definition is flexible depending on the situation where it is applied. For some tasks, such as like gene sequencing, maybe the token, the unit that is of the smallest, the token that is the smallest unit of concern depends on what is the specific target you are looking at. Okay. Anyway, let us represent each of such a token as a vector. Here we consider a 512 dimension vector. How to convert a token to a vector? We'll discuss this later in the embedding part. To be patient, just consider now we have some number of tokens, and each token is represented as a 512 dimensional vector, which is pretty sufficient to represent very rich information for one token. Okay, and for the sake of discussion, let's consider we have 50 tokens, and then we can get dummy input information. Okay, we use torch functionality for that. So let's run this, and maybe let's just have a test. Dummy input dot shape. Okay, just to verify, we have 4 by 50 by 512. Seems to be some kind of reasonable tensor. Okay, so here are some instructions of compute the attention, but I will build that line by line here, and you can read this later with this notebook. Okay. Let's first get the shape so that we can save some typing later. Okay, we call those maybe B, M, and C to be the shape. Okay, and we will consider the linear transformation from C dimension to C dimension. Those transformations are to transform the input data in the rule of querying, in the rule of doing as the K, and in the rule of providing the output values. We call that linear transformation K to be linear, and the input is C and the output is also C. So we do this for all the other components. Having those computational modules defined, of course we haven't specified the parameters at all. We haven't started worrying about the training. Keep that in mind. These are just the random layers. We are verifying the idea of computing attentions. We'll use those layers to process the data into different forms, and let those forms to work with each other to form the attention. So xk is name k, the dummy input, x q then query dummy input and x v to be name value dummy input. Okay, now let's check their shapes. Fine. Basically, we have the same shaped object as the input. Okay, not surprising. Sure. So in the next, we are going to form the attention, compute the attention, and use attention to to formulate the output of this layer.